Dear students, I have sent you the question answers of the chapter named Electric Current, and in this video we will learn some key points associated with this chapter, like what is electric current, what is an electric circuit, then components of electric circuit diagram. So these 4 points that we will study in this video, and in the next class we will be learning the effects of electric current like heating effect, lighting effect, as well as magnetic effect of electric current. So we'll take one by one points. First, electric current. The first point is electric current. Electric current is a form of energy that flows through electric wires or conductors. So electric current is a form of energy like sound, light, heat, wind. These all are forms of energy, and electric current is also a form of energy. But this energy will flow through the wires or conductors. Now, the definition of electric current is flow of electrons or charges from positive terminal to negative terminal. Conventionally, means we are saying electric current is flowing from positive terminal to negative terminal. This is just for the study purpose, but in reality is other way around. This is an electric cell which has two terminals. Positive means the part that now that you're seeing here upside, it is positive, and this bottom side it is negative. In fact, the whole body of the cell is negative. Now we'll see how electric current is flowing inside a cell. Means when we are connecting with the wires, how the electricity flows. You can see that now these are negative charges and these are positive charges. Electric current will start flowing from negative end and it will reach the positive end. This is how electric current flows in a circuit. Means if you are connecting negative to positive terminal, this electric current will start flowing like this. Okay, now this flow of electrons, this flow of these negative charges, which we call electric current. Next we will see what is the unit that we use to measure electric current. To measure electric current we use a unit named ampere. It is represented using capital letter A. Ampere is a large current. We have smaller units like milliampere and microampere, etc. You can understand that now for mass we have kilogram, for time we have seconds. For mass we have kilogram, at the same time we have smaller unit like gram, milligram, etc. The very same way, ampere is a larger current, so we have smaller unit like milliampere and microampere. This symbol, it is a Greek letter, it is called micro. So milliampere and microampere. Milliampere is 1/100th of an ampere, whereas microampere is 1/1 lakh of an ampere. Means it's a very small current. This current could be seen in button batteries, etc. This could be seen in some larger batteries or in cells, etc. Next, you see, to measure electric current, we use a device, an instrument which is called ammeter. If you want to measure how much current is flowing in a circuit, we need to connect a device into that one. The device is named ammeter. This is the diagram of an ammeter. An ammeter, see, if we connect ammeter, this needle, it will show the amount of current that is passing through the circuit. Now we'll take the second point. It is electric circuit. Electric circuit is defined as the path in which electric current flows. Means electric current is just like road for vehicles. For vehicles we have road. For electric current we need a path to travel. That path is known as electric circuit. Electric circuit are of two types. First one, open circuit. The understanding of the open circuit is that in an open circuit switch will be open, yep, or key will be open, or else there will be a broken connection, so that current will not flow from one terminal to another. So open circuit means your better understanding is that you always understand open circuit means switch is open. See this circuit. In this circuit, this represents a key. We are going to learn the components later on. So for now, you just understand that now this shows that it is an open circuit. This part is open. So in an open circuit, switch or key is open. Now second type of circuit is closed circuit. Here switch is closed. Here you see, this is how we draw a key which is closed. When switch is closed, we say it is a closed circuit and electric current flows in it. You can see the difference. In the first picture, this bulb is not glowing, and in the second one, the bulb is glowing. That shows electric current is flowing in the second circuit. Means a circuit in which electric current flows is a closed circuit. Third point was components of electric circuit. So I had shown you electric circuit earlier on, but to draw an electric circuit, we first should know the components of electric circuit. Let's see what are the components of an electric circuit. See, in this table, we have written three components, and the symbols that now will be that now drawing here. First, you see cell, then battery, wire. Wire we have now with joint and without joint. Some wires we will have to join, and some wires will then cross without joining. And we will see what are the conventional symbols that we use to represent this. For a cell, we draw like this. This represents a cell, a larger line and a smaller line. Okay, we are the larger line is positive and smaller line is negative. And when we draw a battery already we have studied that a battery is combination of cells. That means if we put together more than two cells, we call that a battery. So that's how then we have drawn this one. It has got one, two, three batteries, sorry, three cells. These three cells will become a battery. So again, see positive, negative, positive, negative, positive, negative. This is how we draw a battery, three cell battery. Next you see wire. Wires with joint can be drawn like this. Means this line simply represents a wire and we have a joint here. Now if there is no joint, we have to draw a line, then we have to just cross it over. Means you should not then overlap that, just you have to cross like this. Then we say it is a wire without joint. So first three components that we have studied are cell, battery and wire. These three are part of a circuit. We'll study more. See, the other components that we study are bulb, ammeter, voltmeter, switch or key. Bulb we draw like this. This is the conventional symbol that we use to draw a bulb in a circuit. Next, ammeter. This is how we draw ammeter in a circuit. This is the symbol of voltmeter. You can understand that now the first letter of ammeter A is written inside the circle, and this first letter of voltmeter V is written inside the circle here. Now ammeter is used to measure electric current, whereas voltmeter is used to measure the voltage or potential difference in a circuit. These two are two different quantities, two different things. Means current and voltage are totally different things. Current is that which kills you. What voltage is just static. It shows that now what is the difference between, means the amount of current difference between two ends. Voltage doesn't flow, voltage doesn't kill anyone. It is the current that is filling, it is the current that is flowing in a circuit. Voltage is just a static reference. That means how much difference is there between two ends in a of the conductor. Next, switch or key. Switch or key are used to open or close a circuit. If you're drawing switch, this is the diagram that we have to use. This represents open switch, this represents closed switch. Here you can see this is open. That's why this one should be used to draw in a circuit where you are drawing an open circuit. Then if it is closed, you have to bring this handle down and this will become closed circuit. If you are using a key, this is the diagram that you can use. Open key, this is closed key. Instead, only difference is that now at the center of the these two brackets we have to put a dot, a dark dot. This will represent keys. Now you see, you can use it alternatively as well. If you want a switch, you can still draw this what keys diagram. It doesn't matter. So if you're drawing a circuit, you can either use switch or key. It's your wish. Okay. Fourth point that we have studied: circuit diagram and schematic diagram. First, we'll see what is a circuit diagram. An arrangement of components to facilitate flow of electric current. A circuit diagram is an arrangement in which we will put together the components so that electric current can pass. What is a schematic diagram? A circuit diagram drawn by using conventional symbols. See, if you are drawing a circuit using the symbols that we have discussed in the last point, that diagram will be known as schematic diagram. Means if you want to draw a schematic diagram, you need to use the conventional symbols. We will draw a schematic diagram using the symbols that we have studied. See, first we need a source of electric current. We'll draw the battery. So this represents a battery. Next, we need a switch. I have drawn the switch. Next, some wires, then bulb. Then we will complete the circuit. Now you see, this is a circuit in which we have an electric source, then a switch, then some wires, then bulb. So if you have these components, we can draw a simple circuit. So a simple circuit consists of battery, switch and bulb, and connected with wires. Now in this circuit, the electric current will not flow because the switch is open. You can see this part is open. So this one is called an open circuit. So this is an open circuit in which no current flows. Though we have all the components required for making a circuit, this will not uh, represent a complete circuit. This is not a closed continuous path because it is open at switch position. Now we'll draw a closed circuit. See again, battery, then switch, it is closed, you can see, then wires, bulb, then we complete the circuit using the remaining wires. Now see, in the circuit the current must flow because the switch is closed. So if switch is closed, this is called closed circuit and the current must pass in the circuit. And if current passes, the bulb will glow. Now we'll see the graphic in which we will make that now open and closed circuit and how the bulb glows. See, this is a graphic representation of closed and open circuit. You see, when the switch is open, the bulb does not glow. See, the bulb does not glow, and when the switch is closed, the bulb starts glowing. And this simply that's now this negative charges which is flowing. This shows the flow of electricity. So this is how open and closed circuit, and this is what a switch does in a circuit, and this is how electric current flows in a circuit. I hope you have understood. And in the second part, we have to study the effects of electric current like heating effect, lighting effect, and magnetic effects of electric current. Okay, till now, until then you can watch this video and understand these key concepts. Thank you.